Here are the 40 production incidents for modern Salesforce LWC development interviews.
The 40 must-know LWC production incidents.
Welcome to the ultimate Salesforce LWC Masterclass. In technical interviews for senior, lead, and architect roles, you will not be asked basic syntax questions. You will be given broken production scenarios and asked how to fix them. In this video, we cover 40 of the most frequent, high-value production incidents that real enterprise teams face, and exactly how to solve them. If you have prepared for Salesforce LWC interviews by memorizing questions like, what is at wire? Or what is the difference between at API and at track? This video is going to be very different. Imagine this. Your LWC works perfectly in Sandbox. The deployment succeeds. Then, in production, users report that the UI is showing stale data, duplicate records are being created, a data table is updating the wrong row, a flow and LWC are showing different values, or the component suddenly breaks after an administrator changes the Salesforce configuration. These are the problems real LWC developers are expected to solve. In this masterclass, we are going through 40 real-world Salesforce LWC production incidents, from caching, reactivity, Apex communication, lifecycle issues, Datatables, security, performance, and integrations, all the way to deployment failures, metadata evolution, asynchronous processing, and enterprise architecture. And I am not going to simply give you the solution. For every incident, we will look at the production scenario, how I would approach the problem, the technical root cause, the business impact, the production resolution, prevention and best practices, and finally, a pro tip, the kind of practical insight that comes from actually dealing with these problems in enterprise environments. So if you are preparing for a mid-level, senior, lead, or architect-level Salesforce LWC interview, do not just memorize the answer. Learn how to think through the incident, because in a modern Salesforce interview, the question is not always what is LWC. Sometimes it is production is broken, users are complaining, you are the LWC developer on call. What do you do? Let's get into the 40 production incidents that can change the way you approach your next Salesforce LWC interview.
The 13 enterprise categories.
We have divided these 40 production incidents across 13 enterprise categories. Category 1, Data Retrieval and Caching Incidents 1 to 5. Category 2, Reactivity and Rendering Incidents 6 to 9. Category 3, Component Communication Incidents 10 to 12. Category 4, Apex and Server Communication Incidents 13 to 18. Category 5, Concurrency and Record Updates Incidents 19 to 22. Category 6, Data Table and Record Editing Incidents 23 to 24. Category 7, Security Incidents 25 to 28. Category 8, Performance Incidents 29 to 31. Category 9, Integrations and External Libraries Incidents 32 to 33. Category 10, Navigation Incidents 34 to 35. Category 11, Deployment and Environment Incident 36. Category 12, Enterprise Architecture Incident 37. Category 13, Reference Level Engineering and Architecture Incidents 38 to 40. Let's dive right into Category 1.
Category 1, Data Retrieval and Caching.
In modern LWC development, data retrieval is heavily client-side cached for speed. Production failures in this category happen when developers misunderstand the client-side cache boundary, fail to execute proper refresh logic after DML operations, or allow components to fall out of data synchronization.
Category 1, Data Retrieval and Caching Production Incidents.
Here are the first 5 critical production incidents we are going to master in Category 1. Production Incident 1, Stale Data Caused by At-Wire Client-Side Caching. Production Incident 2, Refresh Apex Does Not Refresh the UI. Production Incident 3, At-Wire Never Fires because Reactive Parameters $record ID, $search key are undefined. Production Incident 4, Lightning Data Service LDS Cache returns outdated record values. Production Incident 5, Multiple components display inconsistent data because of independent caches. Understanding client-side caching is the foundation of LWC engineering. So, Let's dive right into Incident 1.
Production Incident 1. A sales exec updated an opportunity stage from qualification to proposal. The record saved successfully, but a custom opportunity summary Lightning Web component continued displaying the old stage. Assuming the update failed, the user clicked save multiple times, resulting in duplicate opportunity updates and frustration. How would you approach this issue?
Answer: this is one of the most common production issues in Lightning Web Components. The database update completes successfully, but the UI continues displaying outdated information because the component is displaying client-side cached data instead of retrieving the latest record. I would approach this by following a structured troubleshooting process like follow. 1. Technical root cause. My first step is to check the database. If the opportunity record shows the new stage in Salesforce, I immediately rule out a backend DML issue. Next, I review the LWC's JavaScript. In this scenario, the component retrieves data using an at-wire call to a custom Apex method. By design, wired Apex caches data on the client side. When the user updated the record likely via an imperative Apex call, the developer forgot to invoke refresh Apex, or the component never invoked refresh Apex after the successful update, leaving the cached response in memory and the UI stale. 2. Business impact. When the UI does not reflect database realities, users lose trust in the system. They assume the application is broken, leading to duplicate opportunity updates, corrupted pipeline reporting, and unnecessary IT support tickets. 3. Production resolution. To fix this, I would ensure that immediately after the imperative update succeeds, and after confirming the database update succeeds, we invoke refresh Apex. A key technical detail here is that I must pass the entire provisioned wired result to refresh Apex, not just the data property. Otherwise, the refresh will silently fail. Once implemented, the component will hit the server, clear the cache, and retrieve the fresh opportunity data. 4. Prevention and best practice. To prevent this, I establish a strict development pattern. Any imperative DML operation must be followed by a targeted cache refresh. Additionally, if the component does not require complex Apex logic, I would evaluate replacing the Apex at wire with standard Lightning Data Service LDS like getRecord, which automatically handles cache invalidation out of the box without needing refresh Apex. Pro tip: interviewers love to trap candidates here, and most importantly, many developers confuse these two approaches. Remember, refresh Apex only refreshes data provisioned by an Apex at wire. If your component uses standard Lightning Data Service getRecord UI, etc., use the appropriate LDS refresh mechanisms instead of assuming refresh Apex will update the UI.
Production Incident 2. A developer built a custom Lightning modal to update case statuses. After saving, the component invokes refresh Apex, and the console shows no errors. However, the underlying case data table does not reflect the new status until the user manually refreshes the browser page. The business is complaining about ghost data. How would you debug this?
Answer: this is a classic silent failure in Lightning Web Components. When refresh Apex executes but the UI does not update and no errors are thrown, it almost always points to an issue with how the wired data is stored or how the refresh function is invoked. Here is my troubleshooting process. 1. Technical root cause. My first step is to inspect the parameter passed to refresh Apex. The most common mistake developers make is passing just the data payload, for example, refresh Apex with this .wired result .data instead of the entire provisioned wired object. If the full object is not passed, refresh Apex fails silently. Another common cause is when the wired data is copied into a separate array used by the data table. Although refresh Apex refreshes the original wired result, the detached array is never reassigned with the new data, so the data table continues displaying stale records. 2. Business impact. Silent UI failures are incredibly dangerous because users assume their work didn't save. This leads to repeated data entry, inflated support tickets reporting system glitches, and a general loss of trust in the custom Salesforce architecture. 3. Production resolution. First, I would verify that Refresh Apex receives the complete provisioned result returned by the @wire service. Next, I would confirm that the refreshed wire data is correctly reassigned to the data table's data source, so the component re-renders with the latest records. If the component uses a wired function to transform or manipulate the data for the data table, I would ensure that the wired function executes correctly and updates the local reactive variable whenever fresh data is provisioned from the server. 4. Prevention and best practice. To prevent this, code reviews must strictly enforce that the result of an Apex @wire is stored as a single, unmodified object, which is then passed directly to Refresh Apex. Furthermore, any data transformations should be handled dynamically in a getter or properly managed within the wired function to maintain the reactive data binding lifecycle. Pro tip: Refresh Apex only refreshes the original wired result. If your data table is bound to another array that was copied from the wired data, remember to update that array after the refresh. Otherwise, the server returns fresh data, but the UI continues displaying stale records, or do not assume Refresh Apex re-renders your UI automatically. It refreshes the wired data source. Your component must still use that refreshed data to update what's rendered on the screen.
Production Incident 3. A custom Lightning component was deployed to display related billing invoice records on an account page. However, when users open the page, the component is completely blank. There are no browser console errors, and the Salesforce debug logs show the Apex backend method was never even called. How would you identify the problem?
Answer: this is a notoriously frustrating issue because of the complete lack of error messages. When an LWC fails silently, and the Apex method is never invoked, one of the most common causes is an issue with the @wire service's reactive parameters. Here is how I would trace the root cause. 1. Technical root cause. The @wire adapter requires all of its dynamic parameters to be valid before it executes. If a reactive parameter, such as $record ID, evaluates to undefined, the wire adapter stays dormant and simply will not fire. This often happens if the component is placed on a page that does not provide a record context, if the parent component hasn't populated or passed the required value yet, or if the property name was misspelled. 2. Business impact. Because there are no visible errors, users assume the system is loading or that no records exist, which can lead to missed billing collections or duplicate data entry. For developers, this silent failure drastically increases debugging time if they do not know exactly where to look. 3. Production resolution. First, I would verify that the required reactive parameter is populated before the component attempts to execute the wire. If the component relies on @AP, I record ID, I would confirm it is running on a Lightning record page. If it is a child component, I would verify the parent populates and passes the value correctly. If the value depends on an asynchronous operation, I would conditionally render the child component using if true only after the required parameter becomes available. 4. Prevention and best practice. Always build a fallback UI, such as a spinner or a no data available illustration, so the component never appears completely blank. Additionally, validate that all reactive parameters are populated before relying on the @wire execution. For wired functions, gracefully handle empty or null data responses and implement appropriate logging to simplify production troubleshooting and future debugging. Pro tip: the $prefix tells the wire service to monitor that property for changes. Whenever the property value changes, for example, when record ID becomes available after page initialization, the wire automatically executes again, without requiring any manual refresh logic.
Production Incident 4. A user clicks a custom Recalculate Margin button, which uses imperative Apex to update an opportunity. The Apex backend update succeeds, but the standard opportunity record details component and a custom LWC using @wire with getRecord both continue showing the old margin. Why did this happen?
Answer: this is a classic cross-boundary caching issue. Lightning Data Service maintains a client-side cache to improve performance and reduce unnecessary server requests. However, when records are updated outside the LDS lifecycle, that cache can become out of sync with the database. Here is my analysis of the problem. 1. Technical root cause. Lightning Data Service automatically manages its client-side cache only when records are modified through standard Lightning UI interactions or native LDS functions such as update record. In this scenario, the custom button performed the record update through an imperative Apex call, bypassing the Lightning Data Service lifecycle. Although the database update completed successfully, the LDS cache remained unaware of the change. As a result, the standard record details component and the custom LWC using @wire with getRecord continued displaying stale data from the existing client-side cache. 2. Business impact. Users get confused when standard record details do not match their recent actions. This often results in users manually refreshing their entire browser page, which defeats the performance benefits of a single-page application. Or worse, making critical financial decisions based on outdated metrics. 3. Production resolution. First, I would verify that the imperative Apex update completed successfully. Once confirmed, I would dispatch a refresh event from the Lightning/refresh module to notify the Lightning framework that the record has changed. This prompts Lightning Data Service to retrieve the latest record data and keeps both standard Lightning components and custom LWCs synchronized. 4. Prevention and best practice. Whenever possible, prefer the standard update record function from Lightning/U. I record API for simple record updates. Because it operates within the Lightning Data Service lifecycle, dependent components are automatically synchronized without requiring additional refresh logic. Reserve Apex for scenarios that require complex business logic or multi-record processing. Pro tip: getRecord notify change has been deprecated in recent Salesforce releases. For modern Lightning web components, use the Lightning/refresh API to synchronize Lightning Data Service after imperative Apex updates.
Production Incident 5. An account Lightning page contains a custom account metrics LWC and the standard record details component. A user updates the account industry on the standard component. The standard UI updates immediately, but the custom metrics LWC continues showing calculations based on the old industry until the browser is manually refreshed. Why are they out of sync?
Answer: this incident occurs when different components on the exact same page rely on isolated, independent caching mechanisms rather than a single source of truth. Here is how I would trace and resolve the disconnect. 1. Technical root cause. My first step would be to identify how each component retrieves its data. The standard record details component uses Lightning Data Service, which maintains its own client-side cache. However, the custom metrics LWC retrieves the same account data through a cacheable Apex @wire method. Because the Lightning Data Service cache and the Apex @wire cache are completely independent, updating the account through the standard UI refreshes only the LDS cache. The Apex @wire cache remains unchanged until it is explicitly refreshed, causing the custom component to continue displaying stale data. 2. Business impact. When multiple components on the same screen display contradictory information, it creates severe data integrity concerns. Users cannot determine which component is showing the truth, leading to operational paralysis, mistrust in the system, and immediate IT escalations. 3. Production resolution. I would first evaluate whether the custom metrics component actually requires Apex. If it only displays standard account fields, I would replace the Apex @wire with getRecord, so both components share the same Lightning Data Service cache. If Apex is genuinely required for complex business logic or calculations, I would implement an appropriate refresh strategy by invoking refresh Apex after the underlying data changes, or by using the Lightning/refresh API, where appropriate to keep all components synchronized. 4. Prevention and best practice. To prevent architectural fragmentation, I enforce a strict single source of truth data retrieval policy. Developers should always default to Lightning Data Service. Custom Apex should only be introduced when LDS limits are hit. If multiple custom components need the same data, they should use a shared cache or communicate via Lightning message service. Pro tip: avoid retrieving the same record through both Lightning Data Service and a cacheable apex at wire on the same page unless there's a clear architectural reason. Whenever possible, use a single data retrieval strategy so all components remain synchronized and require minimal refresh logic.
Category 1 Key Takeaways: Data Retrieval and Caching.
The golden rule of LWC data management is understanding the strict boundary between the Salesforce backend database and the client-side cache. To avoid stale UI and silent data failures, always default to Lightning Data Service for automatic cache synchronization. Strictly reserve custom apex and the refresh apex function for complex operations that cannot be handled by standard native UI APIs.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 1 data management to Category 2 UI rendering.
Now that we have secured how our component retrieves and caches data, we face the next critical phase: rendering that data on the screen. Retrieving backend data flawlessly means nothing if the front-end user interface freezes, crashes out of memory, or fails to visually update when a user interacts with it.
Category 2 Reactivity and rendering.
In modern LWC development, the framework relies on a reactive property model and strict lifecycle hooks to paint the DOM. Production incidents in this category almost always stem from developers misunderstanding how the framework tracks memory addresses, how proxy objects protect data, or how dangerous the rendered callback hook can be without guardrails.
Category 2 Reactivity and rendering production incidents.
Here are the 4 most critical production incidents related to component reactivity and UI rendering of this category. Production Incident 6. Infinite re-render loop caused by incorrect rendered callback logic. Production Incident 7. UI does not re-render because arrays or objects were mutated instead of reassigned. Production Incident 8. Read-only proxy crash caused by mutating at wire data directly. Production Incident 9. Component state is lost after conditional rendering using if true and if false. These bugs are particularly notorious because they often bypass server logs entirely. Because they happen natively in the browser's JavaScript engine, they cause silent UI freezes or immediate client-side crashes that are incredibly hard to trace without proper debugging skills. So, let's dive into Incident 6.
Production Incident 6. A developer added logic to calculate a dynamic CSS height for a custom data table after the component renders. Upon deploying to production, users report that opening the account page completely freezes their Google Chrome browser, forcing them to quit the application. How would you diagnose and fix this UI freeze?
Answer: a complete browser freeze immediately upon loading a Lightning component is the hallmark symptom of an infinite re-render loop. This is almost exclusively caused by improper handling of the component lifecycle. Here is how I would trace and resolve this critical bug. 1. Technical root cause. My first step would be to inspect the rendered callback method for any code that updates reactive properties or component state. The LWC framework invokes rendered callback after every successful render. If the callback modifies a reactive property, the framework schedules another render. Once that render completes, rendered callback executes again, creating a continuous re-render cycle that rapidly consumes browser CPU and memory until the page becomes unresponsive. 2. Business impact. Browser freezes are especially disruptive in Salesforce console applications, where users often work across multiple tabs and active customer interactions. An infinite re-render loop can make the entire browser tab unresponsive, resulting in lost productivity, interrupted customer conversations, and the loss of any unsaved work. 3. Production resolution. My first step would be to temporarily disable the logic inside rendered callback and verify that the page loads normally. Once the root cause is confirmed, I would move any state initialization to connected callback or another appropriate location. If the logic must remain inside rendered callback, I would protect it with a private Boolean flag, such as has rendered so it executes only once during the component lifecycle. 4. Prevention and best practice. Code reviews must strictly enforce the rule that developers should avoid mutating reactive properties or wired data inside rendered callback. State initialization should always happen in connected callback or via getters. The rendered callback hook should be reserved strictly for DOM manipulation or loading third-party libraries, and must always be protected by a Boolean flag. Pro tip: infinite re-render loops occur entirely within the browser's JavaScript engine, not on the Salesforce server. That's why users experience browser freezes instead of apex exceptions or governor limit errors. When troubleshooting this type of incident, use the browser's performance or memory profiling tools to identify components that are re-rendering continuously.
Production Incident 7. A user clicks an Add Product button to add a new line item to a custom quoting component. The backend logic executes perfectly, and console logs confirm the new item is in the array. However, the UI completely fails to display the new row. Why did not the component re-render?
Answer: this is a fundamental reactivity bug in modern web development. When data updates in the background but the UI remains completely unchanged, it is almost always a memory reference issue. Here is how I would diagnose and fix the frozen UI. 1. Technical root cause. My first step would be to verify whether the component is updating the existing array or creating a new one. Lightning Web Components detect changes by observing reactive state updates. If the developer mutates the existing array using methods such as push or splice, the component may not detect the change in the way the template expects. As a result, the underlying data is updated successfully, but the UI continues rendering the previous state because the array reference used by the template was never replaced. 2. Business impact. When a button click yields no visual response, users experience rage clicks. They will click the Add Product button 10 times, assuming the system is slow. Once they finally refresh the page, they discover 10 duplicate products were added to the quote, causing severe data integrity issues. 3. Production resolution. My first step would be to confirm that the backend successfully added the new product. Once verified, I would review how the component updates its local state. Instead of mutating the existing array with push, I would create a new array using the spread operator, such as this dot myArray equals spread of this dot myArray with new item. This creates a new array reference, allowing the framework to detect the change and re-render the component immediately. 4. Prevention and best practice. Developers should follow immutable state management practices by creating new object or array references instead of mutating existing ones. This approach keeps component state predictable, improves rendering reliability, and aligns with modern Lightning Web Component development practices. The @track decorator should only be considered for specific scenarios involving complex nested object mutations, where immutable updates are not practical. Pro tip: do not reach for @track as your first solution. In modern Lightning Web Components, the preferred approach is to update state immutably by creating new object or array references. This keeps your components predictable, easier to debug, and consistent with current Salesforce development best practices.
Production Incident 8. A component retrieves opportunity data using @wire. The developer added logic to append a custom discount field before passing the data to a data table. The feature worked perfectly with local mock data during development. However, after deployment to production, the component failed to load and the browser displayed the error. Cannot assign to read-only property. How would you investigate this issue?
Answer: this is a notorious front-end crash that stems from misunderstanding how the Lightning Web Component framework provisions data from the server. Here is how I would diagnose and fix this strict architectural violation. 1. Technical root cause. My first step would be to identify where the component modifies the wired data. Lightning Web Components provision data returned by @wire as read-only proxy objects to preserve data integrity and support unidirectional data flow. Local mock data used during development consists of normal JavaScript objects, so direct mutations appear to work. However, when the same code runs against real wired data, attempting to modify the provision proxy directly results in a JavaScript type error, preventing the component from rendering successfully. 2. Business impact. Because the exception occurs during the component rendering process, the entire Lightning Web Component fails to display correctly. Users are presented with a blank or partially rendered component, preventing them from completing their work and generating immediate production support incidents. 3. Production resolution. My first step would be to identify where the wired data is being modified. Before performing any transformation, I would create an independent copy of the provisioned data using structured clone function or another appropriate deep cloning technique, depending on browser compatibility and project standards. Once the data is detached from the read-only proxy, I can safely append custom fields or perform additional transformations without affecting the original wired result. 4. Prevention and best practice. Project coding standards should treat all data returned by a wire as immutable. Whenever additional fields, formatting, or calculated values are required, developers should create new objects through mapping or cloning rather than modifying the original wired data. This keeps component state predictable and prevents proxy-related runtime errors. Pro tip: the spread operator spread of wired data creates only a shallow copy, which is perfectly fine for simple top-level changes. However, if your data contains nested objects or arrays that also need to be modified, those nested references remain shared. In such cases, use structured clone function or another appropriate deep cloning technique before performing nested updates.
Production Incident 9. A sales user opens a custom discount approval modal from an opportunity page and enters several discount values. Before submitting, they accidentally close the modal. When they reopen it, all previously entered values have disappeared. The developer confirms the component is wrapped inside, and if true condition, why did this happen?
Answer: this is a common lifecycle issue in Lightning Web Components. Many developers assume conditional directives simply hide a component, but they actually destroy and recreate it. Here is how I would approach this production incident. 1. Technical root cause. My first step would be to verify how the component is being rendered. Components wrapped inside if true if false, or the modern LWC if directives are not merely hidden from view. When the condition evaluates to false, the LWC framework completely removes the component from the DOM, triggering the disconnected callback lifecycle hook and destroying its internal state. When the condition evaluates to true again, the framework creates a brand new component instance, resetting all local variables, draft values, and user-entered information. 2. Business impact. Losing user-entered information frustrates users and severely reduces productivity, especially when completing lengthy forms or approval processes. Users are forced to re-enter data, increasing the likelihood of mistakes and abandoned transactions. 3. Production resolution. My first step would be to determine whether the component actually needs to be destroyed or simply hidden. If the requirement is only to show or hide the UI, I would preserve the component instance by using an appropriate CSS-based visibility approach instead of conditional rendering. If conditional rendering is required, I would hoist the draft state into the parent component or another shared state mechanism so that reopening the component restores the user's previous work. 4. Prevention and best practice. Developers should never rely on local component variables to store important, unsaved user data. If the component is subjected to conditional rendering, any state that must survive component recreation should be decoupled and maintained in a parent container or a shared state mechanism. Pro tip: if preserving user-entered data is more important than destroying the component, consider using a CSS-based visibility approach instead of conditional rendering. This keeps the component instance alive in the DOM and preserves its internal state. Reserve LWC if for scenarios where the component truly needs to be created and destroyed.
Category 2 Key Takeaways. Reactivity and Rendering.
Mastering LWC reactivity requires respecting memory references and lifecycle hooks. Never mutate arrays or objects directly. Always create fresh memory references using the spread operator or structured clone function to trigger UI re-renders. Guard against infinite loops in rendered callback using Boolean flags. And remember that conditional rendering directives like LWC if unmount components and destroy local state completely.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 2, UI rendering to Category 3 component communication.
Now that we have covered how an individual component manages its internal state and renders its UI, we must step back and look at enterprise component architecture. Isolated components mean nothing if they cannot pass state, trigger events, and coordinate business actions with other components across the Lightning page.
Category 3. Component communication.
Salesforce LWCs rely on three primary communication paradigms: passing data down via at API properties, firing custom events up through the shadow DOM, or broadcasting messages horizontally across unrelated components using Lightning Message Service LMS. Production incidents in this category occur when developers mix up event boundaries, break scope rules, or leave zombie subscriptions active in memory.
Category 3. Component communication production incidents.
Here are the three most critical production incidents related to component communication of this category. Production Incident 10. Parent-child communication fails at API or custom events. Production Incident 11. Lightning Message Service LMS subscribers stop receiving updates. Production Incident 12. Duplicate LMS events or zombie subscriptions after navigation. Cross-component communication failures are particularly tricky because they fail silently without throwing standard Apex or JavaScript console errors. So, let's dive right into Incident 10.
Production Incident 10. A child search component dispatches a custom event named Record Select when a user selects a row. However, the parent component's event handler never fires, and the parent UI stays completely frozen. Why is the parent failing to catch the event?
Answer: custom event communication between parent and child components follows strict shadow DOM event bubbling rules and template naming conventions. Here is how I would trace this communication breakdown. 1. Technical root cause. My first step would be to verify how the child component dispatches the event and how the parent listens for it. Custom events follow strict naming conventions and shadow DOM propagation rules. Event names should be lowercase because the template compiler normalizes event listener names. In addition, if the event originates inside a nested child component, it must be configured with bubbles equals true and composed equals true so it can propagate across shadow DOM boundaries and reach the parent component. 2. Business impact. When parent-child messaging fails, multi-step workflows freeze. Users select items in child search bars or pick lists, but the parent form never updates, creating incomplete records and stopping business operations in their tracks. 3. Production resolution. My first step would be to verify that the event is dispatched using a lowercase name and that the parent template listens for the exact same event. Next, I would confirm that the event is configured with bubbles equals true and composed equals true whenever it needs to cross shadow DOM boundaries. Finally, I would verify that the parent handler is correctly bound and executes as expected. 4. Prevention and best practice. Always name custom events using single, all lowercase words like select or search to eliminate template parsing bugs. Furthermore, if a parent needs to execute logic when an incoming at API property changes, the child should use a JavaScript getter and setter on the at API property rather than relying on manual change events. Pro tip: never mutate an at API property inside the child component. Properties decorated with that API are read only to the child. If a child attempts to modify its own at API property directly, LWC throws a runtime error. Always dispatch a custom event to request the parent to change the data instead.
Production Incident 11. Two unrelated custom LWCs sit on a Lightning console page and communicate using Lightning Message Service LMS. When the user opens a second console subtab, the subscriber component in the first tab stops receiving message updates from the publisher. Why did communication break?
Answer: Lightning Message Service enables cross-component communication, but it enforces strict scope restrictions by default. Here is how I would diagnose this silent messaging drop. 1. Technical root cause. My first step would be to review how the subscriber registers with Lightning Message Service. By default, LMS delivers messages only within the active component scope. In console apps and other multi-region interfaces, components outside that scope will not receive published messages unless the subscription explicitly uses application_scope. As a result, publishers and subscribers appear to stop communicating even though both components remain active. 2. Business impact. In high-volume console environments like call centers, dropped LMS messages cause data desynchronization across tabs. A service agent might update a customer's address in one panel, but the surrounding case tools fail to refresh, leading to incorrect orders being processed. 3. Production resolution. I would import application scope from the Lightning/Message Service module and pass scope. Application scope when registering the subscription. This allows the subscriber to receive messages beyond the default active component scope, enabling communication across supported console workspaces and other Lightning regions. 4. Prevention and best practice. Establish an enterprise architecture standard. Any Lightning message channel intended for multi-tab console apps, Experience Cloud, or utility bars must explicitly mandate application scope. Always pair LMS subscriptions with robust null checks on the message context to avoid messaging initialization failures. Pro tip: if your Lightning message service solution must communicate across console tabs, utility bars, or multiple Lightning regions, always evaluate whether application scope is required. Otherwise, components outside the default scope may never receive published messages.
Production Incident 12. Every time a user navigates away from an account page and comes back, the page gets progressively slower. Eventually, when an LMS event publishes once, the subscriber component executes its handler 5 times in a row, triggering duplicate Apex calls and duplicate toast alerts. How do you resolve this?
Answer: duplicate execution and exponential performance degradation after page navigation is the classic signature of a zombie subscription memory leak. Here is my analysis. 1. Technical root cause. My first step would be to review where the component registers its LMS subscription. If subscribe function is executed every time the component initializes without a corresponding unsubscribe function in disconnected callback, each navigation creates another active listener. Over time, multiple subscriptions remain registered, causing every published message to invoke the same handler multiple times and gradually degrading client-side performance. 2. Business impact. Zombie subscriptions cause severe client-side performance degradation. Duplicate Apex controller calls that hit governor limits, and duplicate backend DML operations, such as creating multiple task records for a single user action. 3. Production resolution. My first step would be to confirm that the subscription is created only once during the component lifecycle. I would store the object returned by subscribe function in a class property such as this .subscription. Then, inside disconnected callback, I would invoke unsubscribe with this .subscription and reset the reference to null, ensuring the subscription is cleaned up whenever the component is destroyed. 4. Prevention and best practice. Always practice defensive subscription logic. Inside connected callback, wrap your subscribe function call in a guard condition. If not this .subscription, this double defense pattern a guard check on connect plus mandatory teardown in disconnected callback completely eliminates duplicate listeners even during rapid UI navigation. Pro tip: never call subscribe function directly inside and at wire handler. Wired methods can execute multiple times during a single component lifecycle, which instantly creates duplicate LMS subscriptions on a single page view. Always register LMS subscriptions inside connected callback or an explicit user event handler.
Category 3 Key Takeaways. Component communication.
Enterprise LWC architecture requires clean event boundaries and strict memory teardown. Custom events passing through shadow DOM boundaries must use lowercase names and set bubbles and compose to true. For cross-region and console apps, always specify application scope in Lightning Message Service subscriptions and explicitly call unsubscribe in disconnected callback to eliminate zombie memory leaks.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 3 component communication to Category 4 apex and server communication.
Now that we have secured how components communicate with each other on the client side, we must address the server boundary. Connecting your front-end components to apex controllers opens up the world of asynchronous network execution, governor limits, backend serialization, and server-side data persistence.
Category 4 apex and server communication.
In Salesforce development, Apex acts as the bridge between the LWC client engine and the database. Production incidents in this category occur when developers bypass client-side caching, using unnecessary imperative calls, flood the server with undebounced search requests, trigger asynchronous race conditions, or fail to handle backend DML exceptions gracefully.
Category 4. Apex and Server Communication Production Incidents.
Here are the 6 most critical production incidents related to Apex and server communication of this category. Production Incident 13. Apex serialization and deserialization failures. Production Incident 14. Governor limits exceeded because of excessive Apex calls. Production Incident 15. Duplicate Apex requests triggered by multiple LWCs. Production Incident 16. Search component floods Apex because debouncing is missing. Production Incident 17. Multiple asynchronous Apex calls return out of order. Production Incident 18. Silent failures caused by missing catch function, error callback, or poor exception handling. Server-side communication bugs directly threaten Salesforce governor limits and system stability. So, let's dive right into Incident 13.
Production Incident 13. A component passes a complex JavaScript object to an Apex method. The backend throws an unhandled system.type exception, or receiving fields silently arrive as null in the Apex controller. Why did data serialization fail between LWC and Apex?
Answer: data serialization between the JavaScript client runtime and the Apex backend requires strict data structure mapping. Here is how I would troubleshoot this integration failure. 1. Technical root cause. Serialization failures happen when JavaScript object key structures do not match the target Apex wrapper class. Common causes include key casing mismatches, passing unsupported complex JS types like maps or nested functions, or forgetting to annotate Apex wrapper class instance variables with both at Aura enabled and explicit getter-setter properties. 2. Business impact. When serialization fails, data payloads are dropped or corrupted. Users attempt to save complex forms or configuration matrices, but the backend receives incomplete data, causing transaction rollbacks and broken business workflows. 3. Production resolution. My first step would be to verify that the JavaScript payload structure exactly matches the expected Apex wrapper class. Next, I would ensure every Apex wrapper property is decorated with at Aura enabled and exposed through standard getter-setter methods. For highly dynamic or deeply nested payloads, I would serialize the JavaScript object using JSON.stringify, pass it as a string parameter, and deserialize it in Apex using JSON.deserialize to maintain complete control over the data mapping process. 4. Prevention and best practice. Always maintain strict interface contracts between LWC and Apex. Avoid passing raw, unstructured JavaScript objects. Define strongly typed Apex wrapper classes. Ensure all properties include getter-setters and write unit tests that validate serialization edge cases. Pro tip: an Apex wrapper class variable defined without get, set, will fail silently. If an Apex class property is written as public string status, without explicit getters and setters, the Aura serializer cannot write to it, causing the field to arrive as null in Apex, even if decorated with that Aura enabled.
Production Incident 14. While bulk editing line items in a custom LWC data table, users receive an error: too many SOQL queries, 101 or too many DML statements. 151. The component crashes completely during saving. How do you resolve this server limit crash?
Answer: hitting governor limits from a single UI action is a clear sign that front-end iterative logic is breaking back-end bulkification standards. Here is how I would diagnose this crash. 1. Technical root cause. The front-end code is executing imperative Apex calls inside a JavaScript loop, such as for each or map for every modified row. Each iteration fires a separate HTTP request, causing Apex to execute individual SOQL queries or DML statements per item rather than processing the entire dataset in a single bulk operation. 2. Business impact. Exceeding governor limits immediately terminates the transaction, preventing the requested operation from completing successfully. Users experience failed saves, interrupted business processes, and increased support incidents, while administrators investigate repeated transaction failures. 3. Production resolution. To resolve this, I would refactor the JavaScript controller to remove Apex calls from loops. I would gather all modified rows into a single JavaScript array payload, pass the entire array to a single Apex controller method, and process the records in Apex using bulkified SOQL queries and a single DML operation on the list. 4. Prevention and best practice. Enforce a strict architectural rule. Never invoke imperative Apex inside a client-side loop. Always aggregate front-end data changes into a single list payload and bulkify the back-end Apex method to handle list inputs. Pro tip: never call imperative Apex inside a JavaScript array .map or for each function iteration. Always build a single array payload on the client side. Pass it to an Apex method accepting list of S object, and execute a single DML statement on the backend to guarantee zero governor limit violations.
Production Incident 15. A record page contains 4 separate custom LWCs that all need identical account metric data. Debug logs reveal that loading the page executes 4 separate, identical server calls to the same Apex method, causing unnecessary server load. How do you consolidate these calls?
Answer: executing redundant server calls for identical data across multiple components degrades page performance and wastes server resources. Here is how I would eliminate duplicate requests. 1. Technical root cause. Each component is making its own independent imperative Apex call. Imperative Apex calls bypass the LWC client-side cache completely and execute direct server requests every time. Because the components operate independently, 4 separate network calls fire for identical data. 2. Business impact. Redundant server calls increase page load latency, consume concurrent Apex thread limits, and degrade performance for all users across the organization during peak operational hours. 3. Production resolution. My first step would be to determine whether the data is truly read-only. If so, I would expose the Apex method as at aura enabled with cacheable equals true and retrieve it using at wire wherever appropriate. I would also evaluate whether multiple components can share the same data source through Lightning Data Service or a parent component, reducing unnecessary server requests and improving page performance. 4. Prevention and best practice. Default to cacheable at wire calls for read-only data operations. Reserve imperative Apex strictly for DML operations or non-cacheable transactional logic. Sharing a cacheable wire adapter guarantees automatic request deduplication. Pro tip: avoid multiple imperative Apex calls for identical read-only data on the same page. Whenever possible, use cacheable at wire methods or a shared data retrieval strategy so components can benefit from client-side caching and minimize unnecessary server traffic.
Production Incident 16. A user types ACME into a custom search input. Server logs show that 4 separate Apex SOQL queries were triggered in less than 1 second, one for every single keystroke. Under heavy user concurrency, Salesforce throws 503 service unavailable errors. How do you fix this?
Answer: flooding the server with Apex requests on every single character input is a critical performance flaw that easily crashes production orgs. Here is how I would fix this input handler. 1. Technical root cause. The input fields on change event handler invokes an imperative Apex call immediately upon execution without throttling. As the user types rapidly, an Apex request fires for every single keystroke, exhausting concurrent Apex limits and flooding the database with incomplete SOQL queries. 2. Business impact. Keystroke flooding consumes server thread pools, causing page responsiveness to lag, throwing server errors for concurrent users, and risking org-wide service degradation during peak hours. 3. Production resolution. To resolve this, I would implement a JavaScript debouncing pattern using window.clearTimeout and window.setTimeout. When the user types, the handler clears any pending timer and sets a new timer delayed by 300 milliseconds. The Apex call only fires once the user pauses typing for a full 300 milliseconds, dramatically reducing unnecessary server requests while improving overall application responsiveness. 4. Prevention and best practice. Mandate debouncing on all real-time search inputs, filter boxes, and auto-complete inputs. Standardize a 300 to 500 millisecond debounce threshold across all UI components that trigger server-side queries. Pro tip: always clear the previous timer before setting a new one. Writing window.clear timeout with this .delay timeout immediately before this .delay timeout equals set timeout with parameters guarantees that previous pending keystroke requests are canceled before they ever hit the network.
Production Incident 17. A user quickly clicks Filter 2024 and then clicks Filter 2025. The 2025 request finishes in 100 milliseconds, but the slow 2024 request finishes in 500 milliseconds. The screen ends up displaying 2024 data, even though 2025 was selected last. How do you resolve this race condition?
Answer: displaying stale data due to asynchronous response race conditions is a common, insidious bug in interactive web applications. Here is how I would guarantee data ordering. 1. Technical root cause. Asynchronous JavaScript promises do not guarantee first-in, first-out execution. Server processing time varies based on query complexity and database load. If an earlier, slower request resolves after a later, faster request, the stale response overwrites the current UI state. 2. Business impact. Out-of-order responses show incorrect, stale data that contradicts the user's explicit filter selection, leading to erroneous business reporting and wrong decision-making. 3. Production resolution. To fix this race condition, I would implement a request tracking counter. Every time a user triggers a filter, I increment a class counter, for example, this request ID++, and capture the current ID value for that specific call. When the promise resolves, I check if the captured request ID matches this request ID. If the IDs do not match, the response is stale and I safely discard it. 4. Prevention and best practice. Implement sequence tracking or cancellation. Tokens for all asynchronous calls triggered by rapid user interactions, such as tabs, filters, or paginations to guarantee that stale responses never overwrite current UI state. Pro tip: a simple request counter eliminates complex race conditions. By checking if request ID is not equal to this request ID return inside your promise callback, you instantly drop outdated responses and ensure the UI strictly renders the user's latest selection.
Production Incident 18. A user clicks Submit Order. An Apex exception occurs on the backend due to a validation rule failure, but the LWC loading spinner spins indefinitely or closes without showing any error. No notification appears, leaving the user completely blind. How do you fix this silent failure?
Answer: silent failures degrade user trust and leave transactions hanging in limbo. Proper exception handling must bridge backend Apex errors to the frontend UI. Here is how I would fix this. 1. Technical root cause. The developer invoked an imperative Apex promise without chaining a .catch function block, or failed to extract the error payload from the wired error object. Furthermore, the loading spinner flag was turned off inside then function rather than a finally function block, causing the spinner to lock up permanently when an unhandled exception occurred. 2. Business impact. When errors fail silently, users assume the action succeeded or that the app is permanently broken. They abandon orders, submit duplicate requests, or flood the IT help desk with bug tickets. 3. Production resolution. My first step would be to reproduce the failure and inspect the promise chain. I would ensure every imperative Apex call includes a .catch function block that extracts and displays the backend error message. And I would move all cleanup logic, such as hiding loading spinners, into a finally function block. If the error originates during component rendering, I would also implement the error callback lifecycle hook to capture and handle rendering exceptions gracefully. 4. Prevention and best practice. Enforce mandatory exception handling rules in code reviews. Every imperative Apex promise must have a .catch function and .finally function block, Wire handlers must parse error objects, and top-level components should implement the error callback lifecycle hook to catch child rendering crashes. Pro tip: always reset UI loading spinners inside a .finally function block. If you disable your loading spinner inside .then function, any backend error will skip that block, trapping the user in a permanent spinning lockup. The .finally function block executes guaranteed, regardless of success or exception.
Category 4 Key Takeaways: Apex and Server Communication.
Connecting LWCs to Apex requires strict bulkification and defensive asynchronous handling. Always annotate wrapper class fields with that aura enabled and explicit getter setters. Batch array payloads on the client to avoid governor limit crashes. Use cacheable at wire calls to automatically deduplicate redundant server requests. Debound search inputs with window.set timeout. Track request sequence IDs to prevent race conditions. And always reset UI spinners in a .finally function block.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 4 server communication to Category 5 concurrency and record updates.
Now that we have secured how components communicate with backend Apex controllers, we must address data integrity under multi-user concurrency. When multiple users or background automation processes update the database simultaneously, your component must handle rapid UI interactions, optimistic locking, flow automation synchronization, and backend validation rules.
Category 5, concurrency and record updates.
Concurrency and record update failures happen at the intersection of front-end user actions and back-end transaction processing. Production incidents in this category occur when developers omit submission flags on save buttons, silently overwrite concurrent user updates, fail to synchronize LWCs with flow screen interactions, or hard-code front-end assumptions that break when back-end validation rules change.
Category 5, concurrency and record updates production incidents.
Here are the 4 most critical production incidents related to concurrency and record updates of this category. Production Incident 19. Double-click creates duplicate records. Production Incident 20. Concurrent record editing causes optimistic locking or last write wins issues. Production Incident 21. Flow updates records but the LWC continues showing stale data. Production Incident 22. Validation rule changes break existing save functionality. Concurrency and validation bugs corrupt database integrity and disrupt multi-user enterprise operations. So, let's dive right into Incident 19.
Production Incident 19. A user fills out a custom opportunity creation form in an LWC and rapidly double-clicks the Save button. 2 identical opportunity records are created in Salesforce. Corrupting pipeline metrics. How do you prevent duplicate record creation?
Answer: rapid double-clicking on asynchronous action buttons is one of the oldest and most destructive front-end bugs in web development. Here is how I would diagnose and fix this race condition. 1. Technical root cause. The click event handler invokes an asynchronous DML operation such as imperative apex or LDS create record because the save button was not synchronously disabled on the very first click. The second user click fires a second asynchronous execution thread before the first promise completes, resulting in 2 duplicate records created in the database. 2. Business impact. Duplicate records corrupt sales reporting, trigger duplicate automation workflows such as welcome emails or task creations, and force administrators to spend hours manually merging duplicate data. 3. Production resolution. My first step would be to verify whether multiple save requests are reaching the server. Once confirmed, I would implement a Boolean submission guard flag, for example. This dot is submitting equals true as the very first line inside the click handler, before any asynchronous operation begins. I would bind the button's disabled attribute to this flag and reset it inside a dot finally function block after the operation completes, ensuring duplicate clicks cannot trigger multiple transactions. 4. Prevention and best practice. Establish a mandatory UI design rule. Every save, submit, or DML button must be bound to a reactive is saving Boolean flag that instantly disables the button on click and displays a loading spinner. Pro tip: simply disabling the button in HTML is not enough if the state change is not synchronous. Set your JavaScript Boolean flag. This dot is saving equals true as the absolute first line inside the event handler before any async execution to block duplicate clicks instantly.
Production Incident 20. Two sales reps open the same lead record simultaneously. Rep A updates the phone number and saves. Rep B updates the email address and saves 5 seconds later. Rep B saves silently, overwrites Rep A's phone update without any warning. How do you resolve this concurrency issue?
Answer: silently overriding concurrent user updates is known as the last write wins anti-pattern. Enterprise applications must implement optimistic locking to preserve data integrity. Here is my analysis. 1. Technical root cause. The custom LWC update logic sends a full record update payload via custom Apex, without checking the record's backend last modified date against the loaded client timestamp. Because Apex DML executes blindly, Rep B's update overwrites the entire row, silently erasing Rep A's recent changes. 2. Business impact. Last write wins bugs cause silent data loss. Critical customer updates entered by one team member are overwritten by another, leading to miscommunication, lost sales leads, and corrupted customer histories. 3. Production resolution. My first step would be to determine whether the component can use the standard update record API from Lightning/UI record API. Whenever possible, I would rely on Lightning Data Service because it provides built-in support for detecting conflicting updates. If custom Apex is required, I would compare the record's loaded last modified date with the current database value before performing the update. If a conflict is detected, I would stop the transaction and ask the user to refresh the record before saving again. 4. Prevention and best practice. Default to standard LDS modules, Lightning Record Form, or Update Record for record editing. When custom Apex is required, always pass the loaded last modified date and throw a custom or a handled exception if the database timestamp has changed. Pro tip: never allow custom Apex updates to overwrite records blindly. If multiple users can edit the same record, always implement a version check, such as comparing last modified date before performing the update, so users are warned about conflicting changes instead of silently losing data.
Production Incident 21. An LWC is embedded inside a screen flow on an account page. The flow executes a record update to change the account rating, but the adjacent custom LWC continues displaying the old rating until the user manually refreshes the entire browser. How do you synchronize flow and LWC?
Answer: lack of synchronization between Salesforce flows and embedded LWCs is a frequent complaint in hybrid automation architectures. Here is how I would fix this cache disconnect. 1. Technical root cause. Screen flows execute database DML updates directly on the backend server, because the flow update bypasses the client-side LWC cache. The adjacent LWCs at wire or local state remains unaware of the database modification, leaving the LWC rendering stale pre-flow data. 2. Business impact. Disconnects between flow and LWC create confusing UI experiences. Users complete flow wizard steps, but the page components fail to reflect the updates, leading users to believe the flow automation failed. 3. Production resolution. My first step would be to identify how the flow and LWC exchange information. If the LWC depends on record changes performed by the flow, I would trigger an appropriate refresh strategy after the flow completes, such as using refresh event, refreshing wired data where applicable, or reacting to updated at API properties passed from the flow. The exact approach depends on how the component retrieves its data, but the goal is to ensure the UI always reloads the latest server state after the flow finishes. 4. Prevention and best practice. Establish a consistent synchronization strategy whenever flows and LWCs work together. Clearly define how components are notified of record changes, whether through refreshed input properties, Lightning message service, or an explicit page refresh mechanism, so all components remain synchronized. Pro tip: when an LWC is embedded inside a screen flow, implement a reactive setter on an API input properties. When the flow navigates screens or updates input variables, the API setter fires automatically inside the LWC, allowing you to trigger refresh Apex or Initialize component state seamlessly.
Production Incident 22. An administrator creates a new validation rule requiring a loss reason whenever an opportunity is closed/lost. Immediately, a custom LWC save form starts failing silently or throwing generic save failed errors without showing the validation message. How do you fix this?
Answer: custom LWC forms that break when backend validation rules change indicate brittle error handling and hard-coded schema assumptions. Here is how I would fix this component. 1. Technical root cause. The LWC form hard-coded its save payload to Apex without including the new loss reason field, and its .catch function error handler only displayed generic error text instead of parsing the structured page errors or field errors arrays returned by the Salesforce validation engine. 2. Business impact. Users are blocked from closing opportunities. Generic error messages provide no guidance on missing required fields, causing user frustration, abandoned updates, and urgent escalations to system admins. 3. Production resolution. My first step would be to reproduce the failure and inspect the complete error object returned by the save operation. I would extract the validation details from the appropriate field errors and page errors collections and present the exact message to the user instead of a generic failure notification. Whenever possible, I would also evaluate replacing custom input components with Lightning record edit form, so metadata-driven validation rules are automatically enforced by the platform. 4. Prevention and best practice. Prefer metadata-driven components like Lightning record edit form over custom HTML inputs. Always write utility functions that recursively parse field errors and page errors, so validation rule messages are displayed directly above form inputs. Pro tip: standard Salesforce validation rule failures do not return a simple error.body. Message. Always parse error.body.output. Field errors and error.body.output. Page errors in your error handler to surface the exact validation rule text configured by the admin directly to the user.
Category 5 Key Takeaways. Concurrency and record updates.
Guarding Datatable integrity requires consistent row identity and state management. Always bind key field to the unique Salesforce ID. Clear draft values only after successful saves. Refresh the displayed data after updates, and maintain a master collection of selected record IDs whenever pagination or filtering changes the visible dataset.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 5 Concurrency and updates to Category 6 Datatable and record editing.
Now that we have covered multi-user concurrency and record update logic, we must focus on complex front-end data grids. The Lightning Datatable component is one of the most powerful and widely used components in Salesforce, but its complex draft state, key mapping, and selection lifecycles make it a frequent source of production bugs.
Category 6. Datatable and record editing.
Datatable and record editing failures typically occur when developers misconfigure row identity or fail to preserve client-side state across pagination, filtering, and inline editing operations. Production incidents in this category include incorrect row updates caused by invalid key field mappings, draft values that persist after successful saves, and row selections that disappear as users navigate between pages.
Category 6. Datatable and record editing production incidents.
Here are the 2 most critical production incidents related to datatable and record editing in this category. Production Incident 23. Inline editing updates the wrong row or fails to persist. Production Incident 24. Datatable selection or pagination loses user state. Datatable bugs frustrate power users and directly corrupt bulk data updates. So, let's dive right into Incident 23.
Production Incident 23. A user inline edits the stage column on row 3 in a custom LWC datatable and clicks Save. Unexpectedly, row 1 updates instead, or the save completes with no errors, but yellow edit highlights remain on screen and changes revert on refresh. How do you resolve this?
Answer: unexpected row target updates and persistent edit highlights in Lightning Datatable point directly to key field misconfigurations and unclear draft states. Here is my analysis. 1. Technical root cause. First, the key field attribute on Lightning Datatable was bound to a non-unique or mutable field such as name or an index, instead of the record's true unique ID. When the component mapped draft values back to the dataset, it targeted the wrong row. Second, after executing the save, the developer forgot to explicitly clear the draft values array in JavaScript, causing the data table to retain stale edit state. 2. Business impact. Updating the wrong row in a data grid causes severe data corruption across records. Persistent yellow edit highlights confuse users, leading them to click Save repeatedly and trigger duplicate backend updates. 3. Production resolution. My first step would be to verify that the data table's key field is bound to the record's unique ID instead of a mutable or non-unique value. Next, I would confirm that the save operation completes successfully before clearing this .draft values equals empty array. Finally, I would refresh the displayed data so the data table reflects the latest server state and removes any remaining draft highlights. 4. Prevention and best practice. Always use the record's unique ID as the key field attribute for all data tables. Standardize an inline save pattern where the draft values array is always cleared upon successful promise resolution. Pro tip: always reset this .draft values equals empty array immediately after a successful inline edit save. If you do not clear the draft values array, the data table will keep displaying yellow edit highlights and resend old draft edits on every subsequent save action.
Production Incident 24. A user selects 3 records on page 1 of a paginated custom LWC data table, then clicks Next to go to page 2 and selects 2 more records. When they click Process Selected, only the 2 records from page 2 are processed, and the page 1 selections are completely lost. How do you maintain selection state?
Answer: losing row selection state during pagination or filtering is a widespread bug when building custom paginated datatables. Here is how I would fix this state loss. 1. Technical root cause. My first step would be to review how the component stores row selections across page changes. The data table's selected rows attribute reflects only the rows currently rendered on the active page. If the component replaces the displayed dataset during pagination, without maintaining a separate master collection of selected record IDs, selections from previously viewed pages are lost when the next page is rendered. 2. Business impact. Losing multi-page selections frustrates power users performing bulk operations. Users assume all selected rows across all pages will be processed, resulting in incomplete bulk actions and missed record updates. 3. Production resolution. My first step would be to create a master JavaScript set that stores the selected record IDs independently of the data table. Whenever the on-row selection event fires, I would synchronize the current page selections with this master collection. During pagination, I would restore the visible selections by passing only the matching IDs for the current page back into the selected rows attribute. 4. Prevention and best practice. Never rely solely on event.detail.selected rows for multi-page datatables. Always maintain a master, page-agnostic set of selected record IDs in component memory, and rehydrate the data table selection state whenever the page slice changes. Pro tip: do not rely on event.detail.selected rows alone during pagination. The event.detail.selected rows array only returns rows visible on the currently rendered page. Always maintain a master JavaScript set of record IDs to persist selections seamlessly across page navigation.
Category 6 Key Takeaways. Data table and record editing.
Complex data grid management requires strict key field mapping and client state persistence. Always bind key field equals ID to the record's true unique Salesforce ID to prevent inline edit row targeting errors. Clear this .draft values equals empty array immediately upon successful save to remove yellow edit highlights, and maintain a master, page-agnostic JavaScript set of record IDs to persist row selections across pagination.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 6 Datables to Category 7 Security.
Now that we have covered front-end grid rendering and state persistence, we must turn our attention to enterprise platform security. No matter how elegant your LWC user interface is, failing to enforce backend object security, record sharing, guest user policies, or Lightning Web security architecture will expose sensitive company data or cause severe production outages.
Category 7 Security.
Security incidents in Salesforce typically arise when client-side components and backend services Enforce different security models. Production issues in this category include missing CRUD and field-level security enforcement, inconsistent record visibility caused by sharing configuration, experience cloud guest access restrictions, and Lightning Web security compatibility problems with legacy JavaScript libraries.
Category 7. Security Production Incidents.
Here are the 4 most critical production incidents related to security in this category. Production Incident 25. CRUD or FLS violations expose or hide incorrect data. Production Incident 26. Sharing rules cause users to see different data. Production Incident 27. Experience cloud guest users lose access. Production Incident 28. Lightning Web Security LWC breaks existing JavaScript. Security vulnerabilities expose companies to massive data compliance risks and severe system outages. So, let's dive right into Incident 25.
Production Incident 25. A sales user with read-only profile access to annual revenue opens a custom LWC. The component displays the revenue field and allows the user to edit and save it back to Salesforce, bypassing profile field-level security. How do you enforce CRUD or FLS in LWC and Apex?
Answer: by default, Apex executes in system mode, ignoring object-level CRUD and field-level security FLS. Failing to enforce user permissions in Apex creates severe data compliance vulnerabilities. Here is my analysis. 1. Technical root cause. The custom LWC queried and updated data using a custom Apex controller that lacked user mode security enforcement. Because Apex runs in system mode by default, it bypassed the user's profile FLS restrictions, exposing and updating restricted fields without checking schema accessibility. 2. Business impact. CRUD and FLS violations lead to unauthorized data exposure and data corruption. Non-admin users can view or alter sensitive financial, medical, or PII fields, violating regulatory compliance frameworks like GDPR or HIPAA. 3. Production resolution. My first step would be to identify whether the component uses Lightning Data Service or a custom Apex controller. If it uses Apex, I would refactor the SOQL query to use with user mode and execute DML operations in user mode, wherever appropriate, so object and field-level permissions are automatically enforced. If the use case does not require custom Apex, I would evaluate replacing it with standard Lightning Data Service adapters, such as GetRecord, which natively respect CRUD and field-level security. 4. Prevention and best practice. Prefer standard Lightning Data Service components whenever possible. When custom Apex is mandatory, strictly enforce user mode execution using with user mode in SOQL and as user in DML to guarantee that profile and permission set security is enforced automatically. Pro tip: always use with user mode in Apex SOQL queries. The with user mode clause automatically enforces both object CRUD and field-level security in a single line of code, throwing a security exception if the user lacks field permissions, instead of silently running in system mode.
Production Incident 26. A manager opens an LWC dashboard and sees 50 opportunities. A sales rep opens the exact same LWC dashboard on the exact same account and sees 0 opportunities, assuming the component is broken or data was deleted. How do you resolve this record visibility discrepancy?
Answer: unexpected discrepancies in record visibility between users usually indicate issues with Apex sharing declarations or organization-wide defaults. Here is how I would diagnose this. 1. Technical root cause. My first step would be to inspect how the Apex controller enforces record-level access. A class declared with sharing respects organization-wide defaults, role hierarchy, and sharing rules for the current user. If the controller executes without appropriate sharing enforcement, users with different access levels can see inconsistent results, creating the impression that the component is malfunctioning even though the platform is enforcing different visibility rules. 2. Business impact. Inconsistent record visibility creates operational friction. Reps believe system bugs exist, submit unnecessary support tickets, or miss critical deal updates because sharing rules were misconfigured or poorly communicated. 3. Production resolution. I would inspect the Apex controller class declaration. I would explicitly add with sharing to the class definition to ensure record-level sharing rules, role hierarchies, and OWD are strictly enforced for the running user. If elevated system access is required for a specific operation, I would encapsulate that isolated logic inside a dedicated without sharing inner helper class. 4. Prevention and best practice. Mandate that every Apex controller class invoked by an LWC explicitly declares either with sharing or inherited sharing. Never leave an Apex class without an explicit sharing keyword, as it defaults to system mode execution when called directly from LWC. Pro tip: always make the sharing behavior of an Apex class explicit. Declaring with sharing or inherited sharing clearly documents the intended security model and helps prevent unexpected record visibility issues during future maintenance.
Production Incident 27. A public experience cloud site uses a custom LWC to let unauthenticated site visitors submit lead inquiries. After a security policy update, guest users receive an error occurred and cannot view or submit the form. How do you restore guest user access safely?
Answer: Salesforce guest user security policies strictly lock down unauthenticated access. Resolving guest user failures requires aligning guest profiles, criteria sharing rules, and record ownership. Here is my analysis. 1. Technical root cause. Salesforce security policies enforce private OWD for guest users, revoke view all and modify all data access, and block guest users from owning records. The LWC failed because the guest user profile lacked explicit create or read permissions, missing guest user sharing rules, or attempted to assign newly created records to the guest user. 2. Business impact. Guest user access failures instantly shut down public-facing lead generation forms, self-service portals, and event registration sites, directly impacting customer acquisition and brand reputation. 3. Production resolution. My first step would be to verify the guest user profile permissions, guest user sharing rules, and object ownership configuration. I would confirm that guest users have only the minimum required object and field permissions, ensure the necessary records are shared appropriately, and verify that any newly created records are reassigned to an internal owner rather than the guest user before the transaction completes. 4. Prevention and best practice. Always design guest user LWCs around guest user security policies. Use guest-specific Apex controllers, avoid returning sensitive fields, and automatically reassign record ownership to internal users during DML execution. Pro tip: guest users cannot own records in Salesforce. Any LWC used by guest users to insert records will fail if you attempt to leave the guest user as the record owner. Always explicitly assign the owner ID to an internal queue or system user in your Apex DML logic.
Production Incident 28. After an administrator enables Lightning Web Security (LWS) in production, an LWC utilizing a third-party static resource library, for example chart.js, or a PDF generator, crashes with cryptic JavaScript type error or sandboxing errors. How do you resolve LWS compatibility issues?
Answer: enabling Lightning Web Security (LWS) modernizes client-side sandboxing, but it enforces strict JavaScript distortion rules that can break legacy third-party libraries. Here is how I would fix this. 1. Technical root cause. Unlike legacy Lightning Locker, LWS uses sandboxing distortion filters to protect global primitives. The third-party library failed because it attempted to modify global prototypes like object.prototype, mutate global window objects, or access DOM nodes outside the component's shadow tree, which LWS blocks for cross-site security. 2. Business impact. Third-party library crashes break custom charting components, document generators, and rich text editors, halting critical reporting and document creation workflows across the enterprise. 3. Production resolution. My first step would be to identify exactly where the third-party library fails after Lightning Web Security is enabled. Next, I would upgrade the library to a version that officially supports LWS whenever possible. I would then remove any code that modifies global objects, accesses unsupported browser APIs, or bypasses component boundaries, and ensure all DOM access is performed through this .template.query selector or supported template references. 4. Prevention and best practice. Before enabling LWS or adopting third-party static resource libraries, run the code through Salesforce's LWC console, an LWC distortion viewer tool. Avoid third-party libraries that alter global JS prototypes or attempt cross-namespace DOM access. Pro tip: use the official Salesforce LWC distortion viewer tool to test third-party static resources. If a legacy third-party library cannot be updated and breaks under LWS, encapsulate the library inside an iframe component to isolate its global JS scope completely.
Category 7 Key Takeaways. Security.
Enterprise security requires enforcing user permissions and record isolation across every layer. Always use with user_mode in Apex SOQL queries, and as user in DML to enforce CRUD and FLS automatically. Explicitly declare Apex classes, as with sharing to respect record level OWD. Reassign record owner ID to internal queues when processing guest user submissions, and run third-party JavaScript through the LWC distortion viewer to ensure Sandbox compatibility.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 7 security to Category 8 performance.
Now that we have secured our backend Apex and client-side Sandbox execution, we must optimize front-end application performance. Even a perfectly secure LWC will fail business adoption if rendering large datasets freezes the user's browser, memory leaks crash the DOM, or long Lightning Console usage causes cumulative system degradation.
Category 8 performance.
Performance issues in Lightning Web Components typically arise when components render excessive DOM elements, retain unnecessary memory references, or perform expensive client-side processing. Production incidents in this category include browser freezes caused by rendering large datasets, memory leaks from forgotten event listeners or subscriptions, and gradual performance degradation during long-running Lightning Console sessions.
Category 8 performance production incidents.
Here are the 3 most critical production incidents related to performance in this category. Production Incident 29. Large datasets cause slow rendering or browser freezes. Production Incident 30. Memory leaks caused by forgotten subscriptions, timers, or event listeners. Production Incident 31. Browser performance gradually degrades after long Lightning Console usage. Front-end performance bugs destroy user productivity and crash enterprise browser sessions. So, let's dive right into Incident 29.
Production Incident 29. A custom LWC fetches 5,000 opportunity line items from Apex and renders them using a template loop. Upon loading, the browser tab freezes for 10 seconds. CPU usage maxes out at 100%, and Chrome displays a page unresponsive warning dialog. How do you fix this rendering freeze?
Answer: attempting to render thousands of DOM nodes simultaneously overloads the browser's main layout and painting thread. Here is my analysis of this performance crash. 1. Technical root cause. My first step would be to determine how many records the component attempts to render at once. Rendering thousands of DOM elements in a single operation places significant pressure on the browser's layout, painting, and JavaScript execution processes. As the browser spends more time creating and rendering DOM nodes, the UI becomes unresponsive and users experience long freezes or page unresponsive warnings. 2. Business impact. Browser freezes halt user productivity, trigger page unresponsive crashes, and cause users to force quit their browser, losing unsaved work in other active tabs across the enterprise. 3. Production resolution. My first step would be to reduce the number of records rendered simultaneously. Depending on the business requirement, I would implement server-side pagination, infinite scrolling, or another incremental loading strategy so only a manageable subset of records is displayed at any given time. Whenever appropriate, I would also evaluate standard Lightning components that are optimized for handling large datasets. 4. Prevention and best practice. Avoid rendering unnecessarily large collections in a single template. Design components to retrieve and display data incrementally through pagination, lazy loading, or infinite scrolling so browser rendering remains responsive as datasets grow. Pro tip: optimizing what the browser renders is often more important than optimizing the Apex query itself. Even if the server returns data quickly, rendering thousands of DOM elements simultaneously can still make the application feel slow.
Production Incident 30. A custom LWC attaches a global window resize listener window. Add event listener, sets a polling timer set interval, and subscribes to a platform event. Over time, the browser tab becomes sluggish, and Chrome DevTools shows memory usage continuously climbing without being garbage collected. How do you fix this memory leak?
Answer: uncleared event listeners, timers, and pub/sub subscriptions prevent JavaScript garbage collection, creating severe memory leaks. Here is how I would trace and resolve this leak. 1. Technical root cause. The developer registered global window listeners, polling timers, or pub/sub handlers in connected callback, but failed to detach them in disconnected callback. When the component is unmounted from the DOM, the global window or event bus still holds active closure references to it, preventing the browser's garbage collector from reclaiming the component's memory. 2. Business impact. Uncleared memory leaks cause progressive browser slowdowns, high RAM utilization, and eventual tab crashes during long operational shifts, frustrating users and inflating IT support requests. 3. Production resolution. My first step would be to inspect the component lifecycle and identify every resource created during connected callback. I would verify that each event listener, timer, subscription, or other external resource has a corresponding cleanup operation inside disconnected callback. Finally, I would confirm through browser memory profiling that the component is successfully garbage collected after it is removed from the page. 4. Prevention and best practice. Enforce a mandatory architectural rule. Every global listener, timer, or subscription registered in connected callback must have a corresponding cleanup statement inside disconnected callback. Store all timer IDs and subscription handles on class properties for clean teardown. Pro tip: anything attached to global scope window, document, LMS channels, or EMP/AP I must be detached in disconnected callback. If you forget remove event listener or clear interval, JavaScript cannot garbage collect the unmounted component, creating permanent browser memory leaks.
Production Incident 31. Call center agents keep Salesforce console open all day, opening and closing dozens of record workspace tabs. By mid-afternoon, the browser tab consumes 4 GB of RAM. Switching tabs takes 5 seconds, and the browser frequently crashes with an out-of-memory error. How do you resolve this console degradation?
Answer: progressive performance degradation in single-page applications like Salesforce console stems from cumulative memory leaks across unmounted sub-tabs. Here is my analysis. 1. Technical root cause. My first step would be to determine whether components released all allocated resources when workspace tabs were closed. Lightning Console applications keep the main browser session alive for extended periods, so any event listeners, subscriptions, timers, or cached data that remain after a component is destroyed gradually accumulate in memory. Over time, these retained objects increase browser memory consumption and reduce overall application responsiveness. 2. Business impact. Console slowdowns directly increase customer call handle times, reduce agent productivity, and cause browser crashes during active customer interactions, disrupting call center operations. 3. Production resolution. I would profile the affected console components using Chrome DevTools to identify retained objects and memory growth over time. Next, I would review every custom LWC to ensure disconnected callback releases event listeners, timers, subscriptions, cached data, and other long-lived references. Finally, I would repeat the profiling process after opening and closing multiple workspace tabs to confirm that memory usage stabilizes instead of continuously increasing. 4. Prevention and best practice. Test all console-bound components using Chrome DevTools Memory Profiler. Take heap snapshots before and after opening and closing 20 workspace tabs to verify that detached DOM elements are fully garbage collected. Pro tip: long-running Lightning Console sessions naturally expose memory management problems that short functional tests rarely reveal. Regularly capture heap snapshots in Chrome DevTools after repeated workspace navigation to verify that destroyed components are actually being garbage collected.
Category 8 Key Takeaways. Performance.
Optimizing LWC performance requires DOM virtualization and disciplined memory teardown. Use standard Lightning Datatable to virtualize large datasets and keep the DOM viewport light. Always detach global window event listeners, clear timers, and unsubscribe from LMS channels inside disconnected callback to prevent permanent memory leaks in single-page applications like Salesforce Console.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 8 performance to Category 9 integrations and external libraries.
Now that we have optimized front-end rendering and memory management, the next challenge is integrating external services and third-party libraries. These integrations introduce browser security restrictions, asynchronous resource loading, and cross-origin communication challenges that must be handled carefully in production environments.
Category 9. Integrations and external libraries.
Integrations and external library failures occur when client-side JavaScript attempts to cross security boundaries or load static resources asynchronously without synchronization. Production incidents in this category happen when browser fetch function calls are blocked by CSP and CORS policies, or when third-party libraries loaded via load script crash due to timing race conditions during component initialization.
Category 9. Integrations and external libraries production incidents.
Here are the 2 most critical production incidents related to integrations and external libraries in this category. Production Incident 32. Browser fetch function fails because of CSP or CORS restrictions. Production Incident 33. Third-party libraries load script fail because of race conditions. Integration and static resource bugs break external connectivity and client-side charting tools. So, let's dive right into Incident 32.
Production Incident 32. A developer writes LWC code using native browser fetch function to call an external REST API directly from the client. In the developer sandbox it works, but in production the call fails with a browser console error. Refuse to connect because it violates content security policy. How do you resolve this network block?
Answer: direct client-side HTTP requests from an LWC are governed by strict browser security protocols. Here is my analysis of this cross-origin failure. 1. Technical root cause. Direct browser callouts fail for 2 reasons. First, if the external domain is not configured in Salesforce CSP trusted sites with Connect SRC enabled, the browser's CSP engine blocks the outgoing request. Second, if the external server fails to return access control headers matching Salesforce's domain, the browser's core safety check rejects the response payload. 2. Business impact. Blocked callouts break real-time integrations such as address verification, payment processing, or external shipping calculations, halting business transactions directly in the user interface. 3. Production resolution. My first step would be to identify whether the request is failing because of Salesforce CSP restrictions or the external server's CORS configuration. If the domain is not configured as a CSP trusted site with Connect SRC enabled, I would add it in Salesforce Setup. Next, I would verify that the external REST service returns the required access control, allow origin headers. If the external system cannot support CORS, I would route the integration through Apex using named credentials to perform a secure server-side call-out. 4. Prevention and best practice. Whenever making direct browser callouts, verify both CSP trusted sites and external CORS capabilities during sandbox testing. If external CORS headers cannot be controlled, default to Apex callouts using named credentials to execute server-to-server calls safely. Pro tip: browser fetch function requests execute entirely in the user's browser, so they are subject to browser security policies such as CSP and CORS. If the external system cannot satisfy those requirements, Route the request through Apex using named credentials, where the integration executes as a secure server-side call-out.
Production Incident 33. An LWC uses a third-party charting library loaded via load script from a static resource. On initial page load, the chart renders 80% of the time, but 20% of the time it crashes with chart, is not defined or fails because styles loaded via load style are missing. How do you fix this timing bug?
Answer: intermittent crashes when loading external static resources indicate an asynchronous loading race condition. Here is how I would fix this initialization bug. 1. Technical root cause. My first step would be to review the component's resource loading sequence. The third-party library is loaded asynchronously using load script function, but the component attempts to initialize it before the promise completes. In addition, if load script function and load style function are executed independently, instead of being coordinated through promise.all, JavaScript code may execute before its required CSS resources or target DOM elements are fully available, resulting in intermittent initialization failures. 2. Business impact. Intermittent UI crashes frustrate users and ruin dashboard presentations. Charting components or rich text editors render broken 20% of the time, destroying user confidence in custom analytics tools. 3. Production resolution. My first step would be to ensure all required static resources finish loading before any initialization logic executes. I would load JavaScript and CSS dependencies together using promise.all array of load script and load style. Wait for the promise to resolve successfully, and only then initialize the third-party library. Finally, I would protect the initialization logic with a Boolean guard flag so the resources are loaded only once during the component lifecycle. 4. Prevention and best practice. Always encapsulate static resource loading inside promise.all. Protect the loading block with a Boolean guard flag to ensure load script runs exactly once, and initialize third-party objects only after the promise resolves and DOM elements are ready. Pro tip: whenever multiple JavaScript and CSS resources must be loaded together, coordinate them through promise.all and perform initialization only after the promise resolves successfully. This eliminates timing-related race conditions and ensures all required resources are available before your code executes.
Category 9 Key Takeaways. Integrations and external libraries.
Integrating client-side LWC applications requires respecting security sandboxes and asynchronous loading lifecycles. Direct browser fetch function callouts require both a Salesforce CSP trusted site entry and external server CORS header configuration. Otherwise, proxy callouts through Apex using named credentials. Always load external JavaScript and CSS static resources concurrently using promise.all with load script. Load style with inside rendered callback, protected by a Boolean guard flag.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 9, Integrations, to Category 10, Navigation.
Now that we have covered external integrations and third-party libraries, the next challenge is navigating users safely through Salesforce applications. Navigation introduces new concerns around URL state management, execution context, and component placement, all of which can cause production failures when handled incorrectly.
Category 10, Navigation.
Navigation issues in Lightning Web Components typically occur when components pass excessive state through browser URLs or assume a specific execution context. Production incidents in this category include oversized URL state passed through navigation mixin, resulting in navigation failures, and components that depend on an API record ID crashing when deployed outside Lightning record pages.
Category 10, Navigation Production Incidents.
Here are the 2 most critical production incidents related to navigation in this category. Production Incident 34. Navigation mixin loses state because large objects are passed through URL parameters. Production Incident 35. Component fails because record ID is unavailable outside record context. Navigation state and context bugs break deep linking and crash components on app pages or home pages. So, let's dive right into Incident 34.
Production Incident 34. A user fills out a multi-step wizard LWC. The developer passes a large stringified JSON payload through the state property of navigation mixin.navigate. Upon navigating to the target tab, The browser throws a 414 request URI2 large HTTP error or truncates the data payload completely. How do you pass state safely?
Answer: passing heavy object payloads through URL query parameters violates browser navigation standards. Here is my analysis of this URL state truncation. 1. Technical root cause. My first step would be to inspect what information is being passed through the page reference state. Navigation mixin serializes state values into browser URL parameters, which are intended only for lightweight navigation data. Passing large serialized JSON objects can exceed browser or server URL limits, causing state truncation, navigation failures, or HTTP errors such as 414 request URI2 large. 2. Business impact. Truncated navigation URLs break multi-step checkout or wizard flows. Users lose unsaved draft data when moving between tabs, forcing them to restart complex workflows from scratch. 3. Production resolution. My first step would be to identify which values actually need to be transferred between pages. Instead of passing large serialized JSON objects, I would pass only a lightweight identifier such as a record ID or transaction key in the page reference state. The destination component would then retrieve the complete dataset from Salesforce, session storage, or another shared state mechanism using that identifier. 4. Prevention and best practice. Treat browser URLs strictly as lightweight bookmark references. Pass only primitive IDs or transaction keys in page reference state objects, and use client-side cache or database storage for complex object state. Pro tip: browser and server URL length limits vary across environments. Keep page reference state lightweight by passing only identifiers or small values, and retrieve complex business data after navigation, instead of embedding it directly in the URL.
Production Incident 35. A custom LWC designed for account record pages relies on an API record ID. An administrator places the component on a home page, app page, or utility bar. When users open the page, the component crashes with JavaScript type errors or displays completely blank data. How do you fix this context dependency?
Answer: assuming a component will always execute within a Lightning record page context causes severe runtime failures when deployed to other page types. Here is my analysis. 1. Technical root cause. My first step would be to verify where the component is deployed. The component assumes the container automatically provides an API record ID, which is true for Lightning record pages, but not for home pages, app pages, utility bars, or many Experience Cloud scenarios. When no record context exists, record ID remains undefined, causing dependent at wire adapters, Apex calls, or business logic to fail. 2. Business impact. Context-dependent component crashes throw runtime errors on central home pages or utility bars, disrupting company-wide navigation, and cluttering admin flexipages with broken components. 3. Production resolution. My first step would be to verify whether the component is intended to support multiple page types. I would implement defensive checks to ensure record ID exists before executing any Apex or at-wire logic. If the component is designed only for record pages, I would restrict its placement through the .js-meta.xml configuration. Otherwise, I would provide an alternative mechanism, such as a record picker or configurable input, when no record context is available. 4. Prevention and best practice. Always guard component logic against undefined at API record ID values. Explicitly define placement targets in the component's XML metadata using target configs tag to control where app builders can embed the component. Pro tip: never assume an API record ID is populated. Always guard your JavaScript logic with if not this .record ID checks, and enforce placement rules in your component's .js-meta.xml file, using target configs tag to specify exactly which page types like Lightning __ record page support. Your component.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Category 10 Key Takeaways. Navigation.
Safe application navigation requires respecting browser URL limitations and Lightning page contexts. Never pass large serialized JSON objects through navigation mix-in state parameters. Instead, pass only lightweight identifiers such as record IDs or transaction keys, and retrieve the required data after navigation. Always guard against undefined at a PI record ID values, and use target configs tag in your .js-meta.xml file to control where components can be placed.
Transitioning from Category 10 navigation to Category 11 deployment and environment.
Now that we have covered internal application navigation and component placement contexts, the next challenge is enterprise release management. Building a component that works flawlessly in a sandbox environment is only half the journey. Deploying it to production introduces API version differences, missing metadata, namespace variations, and environment-specific configuration issues that can break an otherwise successful release.
Category 11, deployment and environment.
Deployment and environment failures typically occur when components depend on environment-specific configurations or assumptions that do not exist after deployment. Production incidents in this category include incompatible LWC API versions, missing custom metadata or custom settings, managed package namespace differences, and hard-coded record type IDs or configuration values that exist only in sandbox environments.
Category 11, deployment and environment production incidents.
Here is the critical production incident related to deployment and environment differences in this category. Production Incident 36. Component works in Sandbox but fails after production deployment API version. Metadata, namespace, configuration differences. Deployment bugs cause immediate release rollbacks and production outages after go live. So, let's dive right into Incident 36.
Production Incident 36. An LWC is deployed to production following successful UAT testing in Sandbox. Immediately after deployment, the component fails with JavaScript errors, missing configuration data, or namespace exceptions. Why did the component break after deployment?
Answer: when a component works correctly in Sandbox but fails immediately after deployment, it usually indicates environment-specific dependencies, missing configuration, or deployment inconsistencies rather than a defect in the component's core business logic. Here is how I would approach this production incident. 1. Technical root cause. My first step would be to compare the deployed production configuration with the validated Sandbox deployment. I would verify that no record type IDs, endpoint URLs, or other environment-specific values are hard-coded. Next, I would confirm that the component uses a supported API version tag in the .js-meta.xml file, that all required custom metadata types and supporting configuration were deployed successfully, and that schema imports are used wherever possible to avoid managed package namespace issues. 2. Business impact. Post-deployment failures disrupt major software releases, interrupt critical business processes immediately after go live, increase production support incidents, and often force deployment teams to perform emergency rollbacks during business hours. 3. Production resolution. I would systematically eliminate every environment-specific dependency. Record type IDs and other configuration values would be retrieved dynamically instead of being hard-coded. I would update the component's API version tag where appropriate, verify that all dependent metadata was deployed successfully, replace hard-coded field references with schema imports, and validate the deployment in a production-like environment before the next release. 4. Prevention and best practice. Establish release standards that eliminate environment-specific dependencies. Never hard-code Salesforce IDs. Store configurable values in custom metadata or custom settings. Reference fields through schema imports, and validate deployments using automated deployment pipelines and production like testing environments before every release. Pro tip: schema imports do much more than improve code readability. They automatically resolve managed package namespace prefixes, provide compile time validation, and reduce deployment failures caused by hard-coded field references across different Salesforce environments.
Category 11 key takeaways. Deployment and environment.
Enterprise release stability requires eliminating hard-coded environment dependencies. Never hard-code Salesforce record type IDs or endpoint URLs. Retrieve them dynamically via schema imports or custom metadata types. Always increment API version tag in .js-meta.xml to match current releases, and reference S-object fields via schema imports to resolve managed package namespace prefixes automatically across sandboxes and production.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 11 Deployment to Category 12 Enterprise Architecture.
Now that we have covered deployment safety and release management, we reach the final, highest level of LWC mastery, Enterprise System Architecture. In complex, multi-layered enterprise orgs, front-end LWCs do not exist in isolation. They interact with background Apex triggers, asynchronous flows, platform events, change data capture, and shared Lightning data service caches.
Category 12 Enterprise Architecture.
Enterprise architecture failures occur when multi-layer, asynchronous updates trigger race conditions across independent front-end components. Production incidents in this category happen when background Apex triggers, record-triggered flows, and platform events modify database state out of band, leaving adjacent LWCs rendering contradictory business states because their client caches failed to invalidate in unison.
Category 12 Enterprise Architecture Production Incidents.
Here is the ultimate enterprise architecture incident that tests complete end-to-end platform mastery. Production Incident 37. Cross-layer asynchronous updates, Apex plus flow plus platform events, plus LDS leave different LWCs displaying inconsistent business state. This incident combines caching, asynchronous event buses, and multi-component state synchronization into the ultimate real-world challenge. So, let's dive right into Incident 37.
Production Incident 37. An opportunity update triggers imperative Apex, a record-triggered flow, a platform event, and multiple Lightning Web components. Although every process completes successfully, different LWCs display different values for the same opportunity at the same time. Users report that Salesforce is showing random data. How would you investigate and resolve this enterprise synchronization issue?
Answer. This is a classic enterprise architecture problem where multiple technologies update the same business record through independent execution paths. Although each individual process completes successfully, the overall application loses synchronization because different components refresh their data using different mechanisms. Here is how I would approach this production incident. 1. Technical root cause. My first step would be to trace the complete lifecycle of the opportunity update. I would identify which business processes execute synchronously and which continue asynchronously after the initial transaction. In this scenario, imperative Apex updates the record immediately. A record-triggered flow performs additional field updates. Platform events notify downstream systems asynchronously, while different LWCs retrieve data using Lightning data service. At wire Apex, imperative Apex calls or Lightning message service. Because each layer refreshes independently, components display different snapshots of the same record until every process completes and all caches are synchronized. 2. Business impact. Inconsistent business data across multiple Lightning Web components causes users to lose confidence in the application. Sales representatives may approve incorrect discounts. Managers may make decisions using outdated pipeline information. Duplicate transactions can occur, and production support teams receive high-priority incidents because different users report conflicting values for the same record. 3. Production resolution. My first step would be to identify a single source of truth for the opportunity data and review how every component refreshes its state. I would standardize the synchronization strategy across the application by ensuring all components use the appropriate refresh mechanism for their data source, whether that is Lightning data service, refresh Apex, refresh event, Lightning message service, or platform events. Finally, I would validate the complete end-to-end business process to confirm every component reflects the same business state after all asynchronous processing has finished. 4. Prevention and best practice. Enterprise applications should establish a consistent data synchronization architecture instead of allowing each component to refresh independently. Define a clear ownership model for business data. Minimize duplicate data retrieval strategies. Document refresh responsibilities across Apex, Flow, platform events, and LWCs, and adopt a single source of truth approach wherever possible to keep every layer synchronized. Pro tip: The hardest production bugs are rarely caused by a single technology. They occur at the integration boundaries between multiple technologies. Whenever Apex, Flow, platform events, Lightning Data Service, and Lightning Web Components all participate in the same business transaction, design the synchronization strategy first. A well-defined synchronization architecture prevents inconsistent UI state far more effectively than adding extra refresh calls after deployment.
Category 12 Key Takeaways. Enterprise Architecture.
Harmonizing multi-layer asynchronous execution requires robust event-driven architecture. Never rely on front-end promise chaining to track background automation. When Queuable Apex, platform events, and record-triggered flows update the database out of band, publish a final platform event upon completion. Subscribe all front-end LWCs to this event via EMP API and execute a global refresh event to keep the entire user interface perfectly synchronized.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transitioning from Category 12 to Category 13 Reference Level Engineering.
The first 37 incidents in this series taught you how to debug and optimize component code. However, at the staff engineer and principal architect levels, the problems change. We must now look at how enterprise systems fail organically over time due to metadata evolution, deployment caching, and distributed transaction boundaries.
Category 13. Reference Level Engineering and Architecture.
Reference-level engineering incidents rarely involve a single technology. Instead, they emerge from interactions between deployment infrastructure, metadata evolution, and distributed processing across multiple Salesforce services. Production failures in this category include deployment cache inconsistencies, metadata-driven application breakage, and asynchronous event ordering problems that are difficult to reproduce but highly disruptive in enterprise environments.
Category 13. Reference Level Engineering Production Incidents.
Here are the final 3 incidents that define principal-level technical interviews. Production Incident 38. Metadata cache inconsistency after deployment. Production Incident 39. Dynamic schema evolution breaks existing LWCs. Production Incident 40. Event ordering causes enterprise data corruption. These final 3 scenarios teach you how enterprise Salesforce systems fail at scale. So, let's dive right into Incident 38.
Production Incident 38. Immediately after a production deployment, some users see the new LWC features, while others continue seeing the previous version. Clearing the browser cache fixes the issue for some, but not for everyone. Different users report different UI behavior for the exact same component. How do you resolve this?
Answer: this is a top-tier enterprise deployment issue. When a deployment succeeds but users experience fragmented UI versions, the culprit is rarely just the local browser cache. Here is how I investigate this inconsistency. 1. Technical root cause. My first step would be to determine whether every user is loading the same application resources. Salesforce Lightning relies on multiple caching layers, including browser caches, Content Delivery Network CDNs, static resource caching, and platform metadata caching. Immediately after deployment, these caches may not refresh simultaneously across every user session. If version static resources are not used, different users can temporarily load different JavaScript bundles even though the deployment completed successfully. 2. Business impact. Post-deployment, UI fragmentation causes mass confusion during go-live windows. Support teams waste hours diagnosing ghost bugs that only exist because half the company is running outdated JavaScript bundles in memory. 3. Production resolution. My first step would be to identify which cache layer is serving outdated resources. I would verify the deployed static resource versions, ensure the application references the latest assets, and confirm that users start a new Lightning session when necessary. If custom static resources are involved, I would deploy versioned file names so the application automatically requests the new resource instead of relying on existing cached copies. 4. Prevention and best practice. Never deploy overwrites to existing static resources containing JavaScript or CSS. Always version your static files, for example library_v1 to library_v2, and update the LWC import reference. Because the file name changes, it completely bypasses all CDN and browser caching mechanisms automatically. Pro tip: never overwrite heavily cached static resources. Version your file names, for example, utils_v2.js, so every deployment naturally invalidates cached references and ensures users request the latest assets without relying on manual cache clearing.
Production Incident 39. A Salesforce administrator adds a new required custom field and updates a record type layout. Standard Salesforce pages continue working normally, but multiple custom LWCs suddenly begin throwing JavaScript errors or failing Apex validation in production. How do you engineer components to survive schema evolution?
Answer: this incident separates junior developers from principal engineers. The LWC failed because its front-end code contained hard-coded assumptions about the back-end schema. Here is how I analyze and fix brittle architecture. 1. Technical root cause. The custom component used imperative Apex or rigid HTML forms to construct the DML payload. When the administrator made a new field universally required, the hard-coded Apex payload failed the database insertion. Furthermore, because the custom LWC error handler did not dynamically parse field errors from the DML exception, it threw an unhandled generic JavaScript exception instead of showing the user the missing required field. 2. Business impact. When custom code breaks due to standard declarative configuration changes, agility dies. The business becomes terrified to update page layouts or require new fields because they fear crashing custom engineering components. 3. Production resolution. My first step would be to identify whether the failure is caused by metadata changes or application logic. If the component performs standard record editing, I would evaluate using metadata-driven components such as Lightning Record Edit Form or Lightning/U I Record API. For custom business processes that require Apex, I would validate required fields dynamically using schema, describe information, and ensure validation errors are returned to the LWC in a structured format instead of generic JavaScript exceptions. 4. Prevention and best practice. Custom front-end code should never hard-code business rules. If custom Apex is absolutely necessary, use the schema.describe field result methods dynamically in the Apex controller to identify required fields at runtime, and pass that metadata down to the LWC to render dynamic inputs. Pro tip: enterprise Salesforce applications should be metadata-driven whenever possible. Code that automatically adapts to administrative configuration changes requires significantly less maintenance than code that assumes the schema never changes.
Production Incident 40. A single opportunity update triggers Apex, a record-triggered flow, platform events, asynchronous queuables, and external ERP synchronization. All automations complete successfully, but the final opportunity amount is incorrect because different processes overwrite each other's updates in a different execution order. How do you fix this distributed data corruption?
Answer: this is the ultimate distributed systems challenge. The corruption is not an Apex bug. It is an eventual consistency failure caused by overlapping transaction boundaries and race conditions. Here is how I solve it. 1. Technical root cause. My first step would be to map the complete transaction lifecycle and identify where execution crosses asynchronous boundaries. Synchronous automation completes within a single transaction, but queuable Apex, platform events, and other asynchronous processes execute later with their own transaction context. If an asynchronous process calculates updates using stale record data retrieved before another process commits its changes, later updates can unintentionally overwrite newer business values even though every individual process completes successfully. 2. Business impact. Distributed race conditions silently destroy financial data integrity. The system reports 100% success with 0 error logs, yet the database contains completely corrupted metrics that invalidate financial forecasts. 3. Production resolution. My first step would be to identify every asynchronous process capable of updating the same record. Wherever possible, I would consolidate related business updates into a single transaction. When asynchronous processing is unavoidable, each process should requery the latest record state immediately before performing DML. Validate that no conflicting updates have occurred, and apply business changes using explicit business intent rather than blindly overriding previously calculated values. 4. Prevention and best practice. Enterprise architectures must consolidate same record updates into synchronous before save flows or before update apex triggers. If a process must be asynchronous, it must be stateless. It should pass explicit instructions via platform events rather than relying on stale database queries to calculate its updates. Pro tip: most enterprise data corruption is not caused by failed transactions. It is caused by successful transactions executing in the wrong order. Designing reliable synchronization strategies is often more important than writing efficient business logic.
Category 13 Key Takeaways. Reference Level Engineering.
Principal-level engineering is about designing systems that remain reliable as applications evolve. Version static resources to avoid deployment cache inconsistencies. Build metadata-driven components that adapt to schema changes. And design asynchronous processes that always retrieve the latest record state before performing DML. Enterprise success comes from preventing failures across the entire system, not just within individual components.
Masterclass Conclusion. You are now enterprise ready.
Across these 40 production incidents, you have progressed from Lightning Web Component fundamentals and component communication to Apex integration, security, performance optimization, deployment engineering, and enterprise architecture. More importantly, you have learned how experienced Salesforce engineers investigate production issues, identify root causes, evaluate business impact, implement reliable solutions, and design systems that remain resilient as enterprise applications continue to evolve.
If you found value in this 40-incident masterclass, please like the video and subscribe to the channel so you never miss future deep dives into real-world enterprise engineering. I would also love to hear from you. Leave a comment below telling me which production incident was your favorite, or share one challenging Salesforce production issue you have encountered in your own career. Thank you for watching. Keep building resilient enterprise solutions, and I will see you in the next video.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.